Okay, the backside. Now, I talked a little bit about this in class, and so the purpose of this backside is really for enrichment. And actually, what I'm going to do first, I want to talk about two things here. I want to talk about similar triangles and a little bit of trigonometry. So, the notion of similar triangles. So let's look at this. What's a similar? What does it mean? Similar triangles. It's a real simple idea. If I have two triangles, and we'll make them really nice. So here's one triangle, and then I have another triangle, and it can be drawn inside the other. So I can draw another triangle like this. They're going to be called similar triangles. And we label this one, like the little triangle, is little a, little b, and little c for the hypotenuse. And of course, for the big triangle, instead of using lowercase a, we'll use capital A and capital B, and of course here we use capital C. Right. One of the main areas that fractions first appear is dealing with these similar triangles. Because people understood, or they recognized, that little a divided by a will be equal to little b divided by b, which will also be equal to little c divided by c. If the ratios of these lengths will all be the same if we have this notion of similar triangles. And so what you can do with this idea is that you can actually estimate the height of objects by using triangles. Basically, you have a big triangle, and you can use it if you know the height of a smaller triangle. So as an example, let's go back to part 1 here, to the second page, number 2. It says, as a shadow reckoner of ancient Egypt, you are given the task of measuring the height of an obelisk. Armed with your trusty 8-foot rod, you start at the tip of the shadow and walk towards the obelisk. After 10 feet, you have reached the point where the shadow from the obelisk and the rod meet. From this point, you are 50 feet from the obelisk. All right, so finish the picture. So you want to fill in the spots here. So let's get a different color and underline some things. So you have an 8-foot rod, right? The idea is, you're given the task, you want to measure the height, of course, of the obelisk. Right? And you can't climb the obelisk and drop down with tape measure. It's too tall or too dangerous, whatever. Okay? So the idea, here's my rod, I should label that. This is the rod here, and so we know that's 8 feet tall. And so what happens is you're going to start right here. Here's your guy. Here you are. You're going to start at the tip of the shadow, it says, and walk towards the obelisk 10 feet. So you walk, and after 10 feet, you see the shadow cast by the rod reaches a point where the shadow is cast, right here from the obelisk. Right, so this is just 10 feet right here. And then it says from this point you are 50 feet from the obelisk. So from right here, right, all the way to right here, this is 50 feet. Use ratios to determine the height of the obelisk. Okay, so this is sort of the first application, real application of fractions in a sense. And so there are actually two triangles here. So let's see if you can see the two triangles. We'll draw one in blue. So here's one triangle, right, made with this, where the sun's hitting the obelisk and it comes down. And here's the shadow down here of the obelisk. And then the second triangle we can draw, of course, in green. And it's made by the shadow of the rod, right? The rod, its shadow, right here. With these two triangles, they are similar. So what we can do is we can set up these ratios. We could set up a ratio and say, and we can call this, give this a name, right? We'll call it the height. H is what we're looking for. And we can say, okay, H divided by 8 should equal, right, so the height of this triangle divided by the height of that triangle should equal the length of the blue triangle, which is 50 plus 60. Right, so you have 50 plus 10, 50 plus 10, which is 60, right, divided by the height of the little triangle, which is 10. So you just set up this ratio of these different lengths. Okay, so you say, okay, h over 8 is equal to 60 over 10. And of course, you can solve this for 8. Since you're dividing by 8 to move it over, you simply multiply both sides by 8, so you get h equals 60 divided by 10 times 8. And you can simplify 60 divided by 10 is 6, and then times 8. So this is about 48 feet. And this is what these shadow reckoners did in ancient Egypt. They actually went out and they could measure heights by using the shadows of different objects.